Hey guys, welcome to EduKaji. If you're first time here, allow me to introduce myself. My name is Walter and I'm a scientist as well as a chemistry tutor for the past 8 years.
Right, guys. So this is the Terengganu 2021 trial paper for chemistry paper 2. So we're going to look into how to answer the questions here and discuss some of the important points regarding this particular paper. Okay, so without further ado, let's take a look at the questions together. So let's go to section A first. So for section A, they ask you to answer all questions in this section. Right. So diagram 1 shows the structural formula of two different types of rubber. We have rubber X and also rubber Y. So we see properly, right? Rubber Y actually has these sulfur linkages. So that tells you that it is supposed to be a vulcanized rubber. Okay. So there are two different types of rubber X and rubber Y. So one is unvulcanized and one is vulcanized. So for A, right, they ask you to state the types of rubber X and Y. You can just put that X as unvulcanized rubber. And for Y, you can put that vulcanized rubber. So you get 2 marks over there. All right, and then next we're going to do state one example of product made of rubber Y. So you can just say a lot of things which are actually made out of vulcanized rubber. Vulcanized rubber is technically better than normal unvulcanized rubber. So it normally can be used to make like car tires or shoe soles. So up to you lah. In this case here, I'll just put here car tires. But alternatively, you can also write shoe soles. Some of you buy expensive shoes like Ultra Boost from Adidas. They actually have Continental tires as their materials for the shoe soles. That's why you're paying so much money for it. Okay, all right, and then I got 1 mark over here. And then for C, when rubber X is heated with sulfur, rubber Y is produced, name the process. So of course, you got vulcanized rubber means it must be vulcanization. So the process of creating vulcanized rubber is vulcanization. There you get 1 mark over here. All right. And then let's go to the next one. State one different characteristics between X and rubber Y. So I will say that rubber, of course, the vulcanized rubber have an added advantage because it has heat resistance. One of the key concepts when making car tires. So for example, car tires, you cannot use unvulcanized rubber because it is soft, all right, and it's not heat resistant. So friction between the tires and the road will melt the unvulcanized rubber. So this case here, vulcanized rubber is better because it's heat resistant. So although technically there is, I would say, heat being produced during friction, so it will not affect vulcanized rubber. So the best one over here would just say that rubber Y is more heat resistant. Okay, again, rubber Y is more heat resistant. Okay, done. Let's move on to the next question. So let's go to number 2. Diagram 2 shows a part of the periodic table. Okay, a part of the periodic table of elements. So you got elements A, B, C, D, E, and F, which are not the actual symbols of the elements. So you have to make sure that you only use the alphabets given to you in this case. All right. For example, I know that A is hydrogen and I know D is sodium, F is potassium. But I cannot just simply go and write the actual answer inside. So be very careful. If you write the actual element symbol or the name itself, they will not give you marks for it. So you must follow back the alphabets that they give you. Okay, that's something that you should keep in mind. So based on diagram 2, what is the basic principle used in the arranging of the elements in the periodic table? I would say increasing proton number is the answer. Okay, increasing proton number. Going from left to right. State 2 elements that are placed in the same group. Groups are basically the vertical lines. okay, like this, for example. So I think there's only one lah. In this case, you can put A, D, F if you want to, but it's 2 elements. So I'm going to put like maybe either A, D or A, F or D, F lah. So to be easy, just put there D and F. Okay, A can also be included inside if you want to, but only 2 lah. Write the electron arrangement of atom B. Now, how do we know? So you see, right, B is placed in group 16 and it is in period 2. Period 2 means 2 electron shells, and group 16 means got 6 electrons, 6 valence electrons. So if you've got 6 valence electrons and 2 shells, means the electron arrangement is 2, 6. So you get 1 mark from here. For D, atomic size of E is smaller than atomic size of D. Explain why. So you see over here, right? The size of E is smaller than D. So it has something to do with the attractive forces between the nucleus of the atom and also the electrons. So going from left to right, the atomic size reduces because more and more protons are inside the nucleus, but the electrons are added to the same shell. So the size becomes smaller because there's a stronger attractive forces between the nucleus and also the electrons. Okay, but how are you going to answer this to get 2 marks in total? All right, so you say over here, going across the period, the number of protons in the nucleus of the atoms increases. So technically speaking, the nucleus becomes more positive lah. Then you say that the attractive forces, okay, the attractive forces between the nucleus and the electrons increases. Okay, so when the attractive forces between the nucleus and the electrons increases, it pulls the electrons closer to the middle. So as you go from left to right, more and more protons technically means you should have more and more, you have stronger attractive forces. So you pull the electrons closer, so the size gradually decreases. The size of the atoms gradually decreases. Get all those correct, you should be able to get 5 marks in total. Okay, let's move on to question number 3. So table 3 shows the empirical formula and molecular formula of 2 compounds. We have compound M, which has a molecular formula of C4H8, and we have J, which has an empirical formula of ZnNO32, and same goes for the molecular formula. So there's a blank spot there. I think they want you to write it inside the empirical formula. So you see here, this is C4H8. The 4 and 8 can be divided by 4. So the simplest ratio will be, CH2. Okay, CH2 is the answer. All right, so let's move on to the next one. State the meaning of empirical formula. So empirical formula is the formula that shows the whole number ratio, or simplest whole number ratio of the atoms of an element in a compound. So you put here a chemical formula. That shows the simplest whole number ratio of the atoms of each element in a compound. Then you'll be able to correct already. So the next one you can see here, right, the empirical formula of compound M, which we already did, is basically CH2. So that will be your answer already. And then after that, for C itself, when compound J is heated strongly, it will decompose to form zinc oxide, oxygen gas, and nitrogen dioxide. So write a balanced chemical equation for the decomposition of compound J. So what I'm going to do here is very simple. I'm just going to write the equation, but remember, we are going to write the decomposition for compound J. So since you already know the formula, so it's fine. Okay. So in this case now, very simple. You put that Zn NO3 2, okay, decompose to form zinc oxide plus nitrogen dioxide plus oxygen gas. Okay, but you have to write a balanced chemical equation. Writing the correct formula for each substance, you get technically 1 mark already lah. Okay, but if you balance it up, you get another mark. So you put a 2 over here, you put a 2 over here, you put a 4 over here, and then you should be able to get full marks already. So it's 2 moles of zinc nitrate decomposes to form 2 moles of zinc oxide. You get 4 moles of nitrogen dioxide and 1 mole of oxygen. Then you'll be able to get full marks from here. So next one will be, if 1 mole of compound J is heated, calculate the volume of gas nitrogen dioxide produced at room conditions. Okay, so we will say that based on this chemical equation again, okay, 2 ZnNO3 2 okay, and then you get 2 ZnO plus 4NO2 plus O2, right? So say you've got 1 mole of J heated, what is the volume of NO2 produced? So the ratio, I must compare in terms of ratio. The ratio of zinc nitrate to nitrogen dioxide will be 2 to 4. In a way, we will say it's actually 1 to 2 ratio lah. All right, simplified ratio means it's 1 to 2 ratio lah. So you have 1 mole of compound J means you should have 2 moles of nitrogen dioxide. And they say the volume that you can get, right? So the molar volume at RTP is 24 dm cube per mole. So the volume of NO2 produced will be 2 multiplied by 24 decimeter cube. So your total volume of gas collected is 48 decimeter cube. That's it. Okay, very simple, 48 decimeter cube. Show the calculation, and the final answer you should be able to get 2 marks in total already, right? So again, it's 48. Okay, all right, let's take a look at the next question then, all right? For the next question, for number 4A, CT and IU wash a shirt using seawater. Seawater. I don't know who would wash a shirt using seawater because it's dirty, but maybe they are shredded somewhere. So CT using cleaning agent A while IU using cleaning agent B. All right, table 4.1 shows the molecular formula of the cleaning agent A and B. So this is 2 different structural formulas. So one is technically a soap, A is technically a soap, and B is a detergent. So what is the difference between the two? One can be used in soft water, one can be used in hard water. So detergent in hard water, soap can be used in soft water. So which cleansing agent is soap? So like I said, it's not A is the answer. So you put here A, 1 mark. State the process of making soap. To make soap, it's called saponification. Okay, saponification. So they get 1 mark. And then they say here the reaction between palmitic acid in cooking oil and sodium hydroxide is a process of making soap. Write the chemical equation involved. So supposedly, right, they give you the formula of the palmitic acid already, okay? And during the formation of the soap, right, you just have to remove the H only, all right? All you have to do is just to remove the H and replace it with the sodium ion inside, all right? So therefore, the formula here is very simple. you just copy back the whole thing, which is CH3, CH2, 14, and then you put COOH also. And then because you add it with sodium hydroxide, you just put the sodium hydroxide. Okay, so these are two reactants. Then after that, like I said, you just replace the H with the Na plus. You don't put Na plus, you just put Na. All right, so just copy back and you put here CH3 bracket CH2 14 COONA. Okay, then don't forget, of course, you remove the H really. Where does it go? The H will combine with the hydroxide from the sodium hydroxide. So add together over here, you should be able to get water. Sorry, my equation terbalik. So your final answer here will be plus water. So if you write this correctly, you get 2 marks already. It's actually very simple as long as you understand how this equation works. It is technically a neutralization reaction. Think about it, right? The palmitic acid is an acid. Sodium hydroxide is actually an alkaline solution. So when you add them together, it's like reacting ethanoic acid with sodium hydroxide. It's just that the front part is more complicated, that's it, but it's the same thing technically. Remove the H, plus the OH, get water, then combine the Na towards the part in the palmitic acid. So that you get your sodium palmitate salt. So you have 2 marks. B, diagram 4.2 shows the situation 1 and 2 on cleansing action of agent A and B on dirty clothes and seawater. So what happens is that agent A failed to remove the stain, while agent B can actually remove the stain from the shirt itself. So based on this, you say here, which situation, based on 4.2, which situation the cleaning agent action is less effective? Explain answer. So here, the less effective one is situation number 1. Okay, so you say here, situation number 1. Okay, now after I explain why, you explain in terms of, in this case, you must explain in terms of hot water. So you say inside water is considered as hot water. Okay, seawater contains magnesium and calcium ions, which can form scums with soap. So because they form scum with soap, they won't be able to be used as a, it won't be effective when you remove off the stain. Okay, so you see over here, this produces an insoluble salt. Which reduces the efficiency, okay, which reduces the efficiency of soap. So if you answer that correctly, you should be able to get 3 marks in total. Right, so remember, you must mention that it contains this magnesium and calcium ions that give you 1 mark. Forming scum will give you the 2nd mark. And then explain what happens after that. It produces an insoluble salt and then reduces the efficiency of the soap. You get another 1 mark. So total got 3 marks over there. It's quite easy to score them. You just need to remember the flow. Okay. All right, let's move on to question number 5. 5.1 shows the electron arrangement of sodium chloride compound. Okay, so they give you the electron arrangement, the whole atomic structure straight away. Then they ask you what type of bond is for sodium chloride. So you say that sodium chloride is actually an ionic bond. Okay, so ionic bond will give you 1 mark. And then for number 2 here, how are sodium ion and chloride ion formed from the respective atoms? So very easy. You can say that sodium sodium atom donates one electron to the chlorine atom, and both of them form octet electron configuration. Okay, so it's a very simple thing lah. But as long as you say that sodium donates one electron, and chlorine were to accept the electron, then you get 2 marks already. Okay, so you say over here, sodium atom releases, sodium atom. So in this case here, sodium atom releases 1 electron, and chlorine atom accepts 1 electron. Then you'll be able to get 1 already. Okay, all right, next. B 5.2 shows the electron arrangement of compound X formed when oxygen reacts with carbon. So this one is different. This is actually covalent compound already. So state one property of compound X. You can state any one property that's corresponding to covalent substances. It can be things like insoluble in water. But remember, if you were to write insoluble in water, carbon dioxide apparently is soluble in water. So if you want to write that, you have to be very careful. Okay, don't write that basically, because we all know that carbon dioxide is sparingly soluble in water. It is able to dissolve in water to produce carbonic acid. So if you want to write that, be very careful. I would say you can just write carbon dioxide is a poor conductor of electricity, or it has low melting and boiling point. All those can. So I'll just put here the easy one, poor conductor of electricity. Okay, remember, don't write insoluble in water because it can actually solubilize in water to produce carbonic acid. So I'll say still to a certain extent soluble lah. Okay. 1 mark. Okay, now next to chemical equation below shows the reaction between compound X and ammonia to form urea and water. So complete the balanced chemical equation. That one is very simple. So let's put 2 over here. And then after that, you should get water out of it. So you get 2 marks in total. All right, next, if 24 dm cube of gas X reacts with ammonia, calculate the mass of urea formed. Okay, so gas X is gas X is supposed to be carbon dioxide lah, I assume, right? It's supposed to be that. So in this case over here, 24 dm cube, that should be 1 mole, I think. Okay, so number of mole of gas X is the volume of the gas divided by molar volume in RTP. So molar volume is also 24. So therefore your gas is 1 mole in total. Okay. Then you have to calculate the molar mass of urea, which they already give you. Okay. So based on the equation you see here, carbon dioxide to urea is 1:1 ratio. So the number of mole of urea is also 1 mole. Okay, number of mole of urea is 1 mole. So therefore, we will say that mass of urea is equivalent to 1 mole multiplied by 60 grams. So therefore, 60 grams per mole. Okay, so the answer is 60 grams. Correct answer, you get 2 marks. 60 grams is the answer, because they give you the molar mass really easy. All right, let's go to number 6. Diagram 6 shows the series of action. All right, series of action that involves salt W. So we've got copper oxide plus brown gas plus gas cube. All right, and after that, actually it's salt W forming that, copper oxide, brown gas, and gas Q. And then copper oxide were to dissolve in the solution R, will give you salt W. So since brown gas is produced, I'm thinking this is NO2. All right, brown color gas. Gas Q then is supposed to be oxygen. And if that's the case, then salt W is supposed to be copper 2 nitrate. Okay, and to get copper 2 nitrate from copper oxide, it is technically nitric acid. Okay, now copper 2 nitrate reacts with solution S, will give you copper carbonate. So I think you can choose anything between sodium carbonate because it's soluble, or potassium carbonate also can. All right, so up to you lah. Both also soluble. You have to choose something which is soluble because the bottom part over here is actually double decomposition method. Okay, want to get insoluble salt. So then you must choose something which is soluble to add together lah, I would say. Then after that, if you choose, say, for example, sodium carbonate, then this one will be 2 moles of sodium nitrate. If you're not, then you can choose 2 moles of potassium nitrate also can. So that's your answer. So now that we solved the mystery of every single substance here, then you go to the question straight away. It's easier for you. Still the color of copper oxide. We all know that copper oxide is the only black color copper oxide that you know of in your syllabus. So answer is black. Another thing which is black is just pure carbon powder lah. So in chemistry, it's very simple. You see black means it's most likely copper oxide already. Other than that, it's just pure carbon powder. Either one of those. For A2, the solid of copper oxide can be changed into salt W through the reaction 2. All right, suggest chemical is suitable, changing the solid of copper oxide to salt W, which I already suggested just now. You can either put HNO3 or you can put nitric acid. Okay, now when do we choose to use name, or when do we choose to put the formula? So if they didn't ask you to name the substance, you can choose to put the formula. If they mention the word name this substance, you must write the name in whole. So you can't write the chemical formula instead. So remember that. For B, write a chemical equation to represent the decomposition of salt W by heat. So you can put here Cu NO32 broken down to produce CuO plus NO2 plus O2. All right, same thing. You just have to balance it up, and then you'll be able to get the full answer. Then you get 2 marks. Okay, correct formula 1 mark. Balancing chemical equation will give you another mark. All right, understand? And then let's move on to the next one. So state the observation when excess ammonia solution is added to the solution of salt W. Again, salt W is copper nitrate. It's asking you if you were to add ammonia solution inside copper nitrate. Now, when you add ammonia solution, this is actually a test for cation. So specifically, it's a test for the presence of Cu2+. So what we will get is actually a blue color precipitate, which will dissolve in excess ammonia to produce a dark blue solution. Okay, so you put here a blue precipitate is formed. That will dissolve in excess ammonia to form a dark blue solution. Okay, the first part mentioning blue precipitate will give you 1 mark already. Then you say dissolve in excess to produce a dark blue solution, you will get another 1 mark. So you have to write both at the same time to get 2 marks in total. That's the answer. All right, so let's go on to D. For D, based on reaction 3, solution S was added into salt W to produce 2 types of salt. There are CuCO3 and Z solution. Describe a chemical test to identify the anion present in Z solution. So they are asking you to identify the anion. In this case, this is supposed to be the nitrate ion lah, because you get either sodium nitrate or you get potassium nitrate, depending on what you use. So I think it's very simple over here. All you have to do is just to write, you add acid first, then iron 2 sulfate. And then after that, you add a little bit of concentrated sulfuric acid along the wall. And then there's a brown ring formation, okay? So you see over here, very simple, add 2 cm cube of dilute sulfuric acid into the solution. Okay, then you say over there, add 2 cm cube of Fe SO4 solution into the same mixture. And then finally, you say slowly add or gently add concentrated sulfuric acid okay, H2SO4 on the walls of the test tube. A brown ring will form. The outcome itself will give you 1 mark already. So you must explain everything in detail. Then you'll be able to score all 3 marks in this case. All right, so that's a test for anion. Very simple. Let's go number 7. Diagram 7 shows a bottle of liquid disinfection, liquid disinfectant, I think. I think most likely it's liquid hand sanitizer. It's not disinfection. Disinfectant is actually quite strong to be used on the hand, so it's a hand sanitizer. Okay, it contains compound X. Besides compound X, compound Y with the fruity smell can also be found in liquid disinfectant. So state the homologous series of compound X. So it's obviously an alcohol because you can see it's an OH group over here. So you can put that alcohol. 1 mark. State the name of compound X. Compound X is supposed to be ethanol because it's a 2-carbon alcohol. So supposed to be ethanol. Very good. And then let's see the next one. Write a chemical equation for the combustion of X. So just write C2H5OH plus O2. You get CO2 plus H2O. Write the correct formula, you get 1 mark already. Now balancing the equation will get only 1 mark. So you put a 3 over here, you put a 2 over here, and put a 3 over here. Then you'll be able to get 2 marks in total. Then that is supposed to be what you can get. Just double check the number of hydrogen and oxygen, all those things. Then if it's correct, you get correct. All right, compound Y is a propyl butanoate, which can be prepared through reaction Z between alcohol P and compound Q. So name reaction Z. So the process of producing ester is called esterification. Okay, so you can put here esterification. Okay, and then they say here, state the name of compound Q. So just now we have this one, YX, right? This is substance X. And then they also say just now Y is the ester. So X is the alcohol, and then, sorry, X is the alcohol, and Y is the ester itself. So compound Q is the reaction between P and Q, okay? So propyl comes from the alcohol itself, so the alcohol is supposed to be propanol. Okay, naming of ester alcohol name comes first. So propyl means propanol. Butanoate means it comes from butanoic acid. So this is supposed to be P and Q. So Q is butanoic Noic acid. Okay, and then I'll ask you to write a balanced chemical equation in this case. So you will have propanol first. Plus the butanoic acid. You will get the what's it called? Propyl butanoic. Okay, so it's the same thing. Just right now COO, and after that it goes C3H7 plus the removal of water molecule. Balanced chemical equation will give you 2 marks in total. Right, now C, during COVID-19 pandemic, usage of liquid sanitizer that contains up to 70% of ethanol is necessary measure to prevent spreading of germs. Based on medical expert, washing and hand routine using soap and water is more effective than using liquid sanitizer. Suggest why liquid sanitizer is preferred than traditional soap and water routine. So I think it's because it's easier to use, right? And also you don't need water. So you see over here, no rinsing is required when liquid sanitizer is used. They'll give you 1 mark because that's the advantage. And then you can also say that it is easier to carry around. Small, okay, usually small bottle, okay. So small bottle of sanitizer is easier to be carried around. Okay, then you get 2 marks in total. So it's actually quite interesting. All right, so let's move on to the next one. Diagram 8 shows the apparatus set up by students to carry out an experiment to determine the heat of neutralization between nitric acid and sodium hydroxide solution. So we have a 25 cm cube of 1.0 mole per dm cube of sodium hydroxide and 1 mole per dm cube of 25 cm cube or 1 mole per dm cube of nitric acid. Okay, now, so we have equal volume and concentration of nitric acid. So since this is single, or should I say monobasic base, and this is a monoprotic acid, then it should be just enough to react with each other lah. Okay, so that's the good part about that. So the result of the experiment shown in table 8, so you can see that the initial temperature of nitric acid and sodium hydroxide is the same. In this case, it will be 28. And then the final temperature achieved is 34. So I will say that the difference of temperature, in this case, temperature change theta is equivalent to 6 degrees Celsius. Okay, so what's the meaning of heat of neutralization in this experiment? Okay, now you see in this experiment. So this is actually referring to an operational definition. Okay, operational definition. So the answer is very simple. You can just put here heat release. Okay, heat release. All right, when 1 mole is formed, when 1 mole of water, when 1 mole of water is formed from the reaction between nitric acid and sodium hydroxide. Okay, very specific that we mention the word nitric acid and sodium hydroxide. Usually it's just an acid and a base, or acid and alkaline substance. So you don't have to actually mention the name of it. But this one's obviously very specific, nitric acid and sodium hydroxide, right? So that's how we know. B, suggest what apparatus can be used to replace polystyrene cup in this experiment. So we can use here plastic cup. Okay, because plastic also considered as a heat insulator. But of course, the best is still polystyrene because it can reduce the heat loss more effectively. Okay, then based on experiment, it's supposed to calculate the heat change, which is Q in this case. So Q is equivalent to MC theta. So M is supposed to be 25 cm cubed plus 25. So total is 50. Okay, so 50 grams there. And then your C is supposed to be 4.2 because of this one. And then your theta earlier is 6 degrees Celsius after you have calculated. So therefore, you just substitute the value in. It will be 50 times 4.2 times 6 degrees Celsius. So that should give you a total of 1,260 joules, which I think you just convert it into kilojoules straight away because we need it for the calculation for delta H. Then they ask you to calculate the heat of neutralization, right? So they find out what's the number of mole first up because the formula is delta H is equivalent to Q over N. So N over here, you can just pick any of the solution and you use this formula MV over 1,000. So that should be, this now was 1, right? If I'm not mistaken, it's 1. Yeah, it's 1 and it's 25. So 1 times 25 divide by 1,000. So that would be 0.025 mole, not mistaken. Yep, correct, 0.025 mole. Okay, and after that, what you do is you just take the Q just now in kilojoules and divide it by 0.025 mole. Then your answer here, your final answer should be negative 50.4 kilojoules per mole. Don't forget the minus here because the minus actually shows that it is a exothermic reaction. So if you don't put this in, it's considered as wrong. Okay, so make sure you put a negative there to show it's exothermic. If it's endothermic, you put a plus sign. Okay, so in this case, heat release, heat of neutralization is always negative because it's always increasing in temperature. So you can just use that as an answer straight away. Okay, all right. That's more than a D. So if the experiment is repeated by using 25 cm cube of 1.0 mole per dm cube of sulfuric acid to replace nitric acid, predict the value of the heat of neutralization for the experiment. We will say in this case the same. Okay. Now, of course, you'll be wondering why, right? Because supposedly sulfuric acid has double the amount of H+. It doesn't matter because the limiting factor now is your sodium hydroxide. You may have extra H+, you may have the rate of reaction increased, but the amount of water formed will still be the same because the amount of sodium hydroxide is the same. The concentration and volume of sodium hydroxide is still the same. So therefore, we will then say that this is actually the same. Okay, so how are you going to explain that in terms of the question itself, right? You can just say that same because the amount of the amount of sodium hydroxide, the concentration of hydroxide ions is the same. It's the limiting factor. So your hydrogen ions will be in excess. So you say here the number of mole water is kind of number of mole of water produced remains the same because the amount of hydroxide ions is the same. So you get 1 mark over there. Very simple. Okay, then they say here, a mountain climber went to warm his hands and feet using a special pack that contains chemicals. Hence, in the pack contains anhydrous calcium chloride that dissolves in water and releases the heat of 85 kilojoules per mole. Draw the energy level diagram to show the change in heat occur. So they give you this equation, so you follow back the same thing. So to draw this diagram is very simple. Okay, you just have to draw a reactant got more energy than the products. And then you put a straight line across. So this is energy. Okay. And then after that, what you can do is that the reactant is CaCl2. And then you get Ca2 plus 2Cl minus. And then you put a delta H value of negative 85 kilojoules per mole. Remember, again, to put the negative in front or else it's wrong, because that's to indicate that it is an exothermic reaction. Releases heat of 85 kilojoules per mole. So if you draw this correctly, you should be able to get 2 marks in total. Okay, let's move on to section B, question number 9. All right, answer any one of the questions from this section. So diagram 9 shows 2 situations when you're grilling a meat. So you can see here 500 grams of meat for both sides. One is, you can see there is a whole chunk of meat. The other one is a smaller piece, technically. So based on diagram 9, which situation will the meat cook faster and state the factor that affect the rate of cooking? So we'll say in situation A. Okay, situation A, the factor involved will be is the size of particle or size of the meat. Also can actually. Or you can put here total surface area of meat. Okay, size of particles, total surface area. Not particle because there's no particle there. I just say meat better. Okay, factor involved is the size of meat or total surface area of the meat exposed to the heat. All right, so that's the answer. All right, then 2 marks is given to you. Let's move on to the next question. Based on table 9, shows information of reactants and the temperature used in 3 experimental factors affecting rate of reaction. Reaction between a calcium carbonate and hydrochloric acid produce gas X, which makes lime water chalky. Okay, so one is that you use excess calcium carbonate chips with this much and concentration of hydrochloric acid, 35 degrees Celsius. The other one, you use calcium carbonate chips as well with 30 cm3 or 0.5 mole per dm cube of hydrochloric acid, which is a higher temperature, 45. And the last one, you use excess calcium carbonate chips and also 30 cm3 of 1 mole per dm cube of hydrochloric acid at 45, 20 uni. So you can see that the rate of reaction increases from number 1 to number 3. So what is meant by the rate of reaction and state the name of gas X produced? So rate of reaction is the change in quantity of product or reactant over time. So you can put here rate of reaction is the change in quantity of reactants, or you can choose to say products as well, over time. Okay, so that'll give you 1 mark, and then gas X produced will be carbon dioxide. But they say name, so you see, when I say they say the word name is, you must put the name. You can just write the formula. So you put here carbon dioxide. 2 marks. Okay, and then say here, write a chemical equation for the reaction between calcium carbonate and hydrochloric acid. Calculate the volume of carbon dioxide produced, maximum volume. So we'll start with the chemical equation. So there will be CaCO3 plus 2HCl. And then you have your CaCl2 plus CO2 plus H2O. Okay, so give you 1 mark already. Usually 2 marks for the chemical equation. 2 marks for the chemical equation. So here we'll give you 2 marks already. Then next you see, right, they already give you the volume and concentration of acid. So what we're going to do is we're going to use MV1000. So number of mole of HCl will be MV over 1000. So you can see here it's not 30 and 0.5. So 0.5 times 30 divide by 1000. Right, then you're supposed to get 0.015 mole. Okay, 0.015 mole. So now you see now, right, the ratio between acid to carbon dioxide gas is 2 to 1. So the number of mole of CO2 produced is actually half. So it's 0.015 divided by 2. So then you will get 0.0075 mole of carbon dioxide. Then you multiply it with the molar volume at RTP. So the maximum volume of CO2 you can get will be 0.0075 multiplied by 24 dm cubed. Then your answer, final answer is supposed to be 0.18. Okay, 0.18 decimeter cube. All right, so therefore that's the answer. Write the unit correctly, everything is done, you'll get 5 marks in total. So 3 marks for calculation and the final answer. So total will give you 5 marks. Very simple. Okay, yeah, so calculate the average rate of reaction for experiment number 2. So the average rate of reaction for experiment 2 is total gas produced is 50 and 50 cm cube of 30 seconds. So rate of reaction is equivalent to 50 cm cube divided by 30 seconds. So you will get a total of 1.67 cm cube per second. Then you get 1 mark. All right, then you're supposed to compare the rate of reaction between experiment 1 and 2. So obviously, experiment 1 took a longer time compared to 2. So the rate of reaction for experiment 2 is higher. But you're supposed to explain it in terms of collision theory also. They got 10 marks in total. Quite a lot of marks to cover, actually. But let's just talk about the simple points only, okay? So in exam, you can write in point form for essay questions. So you don't have to write everything in one single sentence. All right, you can spread it into different points as well. So for experiment 1 and 2, you can compare which one is smaller. So I'll write in point form for you, easier. So experiment 1 and 2 here, you can say that rate of experiment 1 is lesser than rate of experiment 2. Don't write in point form. I'm only writing in point form for you to understand better. Okay, in exam, although you can write in point form, you can write don't write in short form. You can write in point form, but don't write in short form. Okay, I'm writing in short form so that I want to explain to you in an easier way. Okay, so make sure you write everything in full point form, but full sentences. Right, so rate of experiment 1 and is lesser than experiment 2. And then what happens next is actually explain why. So of course, one uses, you can see, right, one uses a higher temperature, 45, and one uses a lesser. Although they are using the same marble chips. So you say here, temperature of acid in experiment 2 is higher. Okay, now explain why not? Because then it will cause the kinetic energy of particles is higher. Then of course explain that movement speed increase and after that you say here more collisions and effective collisions between reactant particles. Okay, so therefore the rate of reaction increases. So this one will give you 5 marks in total already for the first one, comparison. And then the second comparison is based on concentration. Okay, so concentration you must explain also in the form of more H plus ions present inside and whatnot. So this will be for experiment number 2. So for experiment number 2 here, a comparison between experiment 2 and 3. So explain that experiment 3 has higher concentration of acid. Well, before that, you have to explain the rate of reaction. So you can just say here that rate of experiment 3 is greater than rate of experiment 2. Okay. Then you say here that experiment 2 has a higher concentration of HCl. So this leads to higher concentration of hydrogen ions. Okay, so then they will lead to more collisions, or you can say frequency of collision increases. All right, frequency of collisions between reactant particles increases. So then you have to say more effective collisions. In shorter period of time. And then you'll be able to get full marks there as well. All right. So that is the how you can explain that in terms of the collision theory for the both of the experiments. There are different factors involved because in this case it's because one is about temperature and the other one is about concentration. So you have to mention both lah. Get all the marks correctly, you should be able to get 10 marks. It's actually quite easy if you know the sequence of it. Always remember to mention the number of collisions and also the effective collisions in this case, all right? Only catalyst is a bit different. Catalyst you have to explain in terms of activation energy. But for the rest of it, it's mostly all about number of collisions and number of effective collisions. All right, so that's done. Let's move on to the next question. All right, for number 10, the concentration of different pH value. So in this case here, you have solution P and Q with the same concentration but different pH value. So over here, what happens is that they say here, the pH value less than 7 for P reacts with copper oxide to produce copper 2 nitrate and water. And then the other one is the pH value less than 7 reacts with sodium hydroxide solution to produce sodium ethanoate and water. So you see properly, right? If it produces a nitrate salt, then most likely P is nitric acid. And the other salt is actually sodium ethanoate. Means this is most likely ethanoic acid already. The salt produced depends on the acid that's being used also. So this is the one way that we can know what is what lah. Okay, so based on table 10.1, name solution P and Q, which we already did lah. P is supposed to be nitric acid and Q is supposed to be ethanoic acid. But you see, they say name the acid. So you cannot write the formula, so you must write the name. So P is supposed to be nitric acid and Q is ethanoic acid. Okay, so ethanoic acid. All right, and then we have, okay, which one has a higher pH value? Explain your answer. So Q lah, okay, Q has a higher pH value. Compared to P. Why? Because Q is a big acid, ma. All right, you can say that basically Q dissociates partially in water to have a lesser concentration of ions. Or you can just straight away compare and say that Q has lesser concentration of H plus. Also can already give you 4 marks in total. Okay, so 1 mark, 1 mark, 1 mark, 1 mark. Total, 4 marks in total. All right, B, diagram 10.2 shows the setup apparatus that is using in titration process of acid and alkali. We have sulfuric acid added to 20 cm cube of 0.5 mole per dm cube of phenolphthalein indicator. All right, state the type of reaction occurred in the conical flask and write the chemical equation. Hence, calculate the molarity of the sulfuric acid if the endpoint of titration is 10 cm cube. Okay, so I would say the type of reaction here will be neutralization. Okay, so then after that, you have to write in the rest. So you say here the molarity, right? So they ask you to write a chemical equation also, which is 2 marks in total. So H2SO4, you know, H2SO4 plus NaOH, right? It's it's kalium. So it's H2SO4 plus 2KOH. Okay, let me just rub that off again. Sorry. 2KOH. And you get K2SO4 plus 2H2O. Okay, right now, in terms of the ratio is 1:2 ratio. So let's calculate the number of mole of potassium hydroxide first. Okay, so number of mole of KOH, we can use MV over 1000 in this case. So just now we saw 0.520 divided by 1000. So in this case, you'll be able to get no, actually, you know what? I got a simpler way to do this. Sorry. I'm having an old habit to use the short method. So there's a faster method here. You can use MAVA divided by MBVB equals to A over B. Okay, where where this part here is for the acid and this part here is for the KOH. It doesn't actually matter, but you know, it's easier to see that way. So right now our idea is to get MA. All right, MA is the molarity of the acid itself. And the ratio is 1:2 ratio, right? So it's easy to see that. So what we can do is we can substitute the value in. Currently what I have is I want to find the MA. My VA is supposed to be 10 according to here. Okay, and then after that divided by the MB, which is 0.5, and the volume of acid, sorry, the volume of sodium potassium hydroxide, sorry. The volume of potassium hydroxide is 20 and divide by 1/2. Okay, so making Ma as a subject. Okay, if you use your math skills, you'll be able to calculate it correctly. And the Ma is supposed to be 0.5 mole per dm cube. Okay, so this is actually a shortcut method, easier for you to remember. So again, MAVA here refers to the molarity and the volume of acid used. This one is the molarity and the volume of the base or alkaline solution used. Okay, then it'll be the ratio A and B. The ratio I show you here, right, is 1:2. So you just put here 1:2. All right, and then using your math skills, just shuffle the equation around. All right, it's basic. Okay, if you don't know the step over here, okay, you can actually use this, reshuffle everything. So it will be technically MA is equivalent to 0.5 times 20 divided by 2 times 10 like that. Then you'll be able to get your answer already, which is 0.5. So do all that correctly, you should be able to get 6 marks in total. Quite simple, I would say. All right, for C then, table 10.3 shows the setup of the apparatus for 2 experiments to investigate the electrical conductivity and one of the acid properties when hydrogen chloride dissolves in solvent X and solvent Y. So one is the solvent X, the light bulb lights up, and then in Y it doesn't. So most likely X here is water, Y here is an organic solvent. Okay, do take note that acid is a unique substance, just like alcohol, which can dissolve in both dissolve in both water and organic solvent. And after that, number 2 here, if HCl plus solvent X reacts with calcium carbonate, you can see that the lime water turns cloudy, supposedly, but in Y, nothing happens, supposedly. So suggest solvent X and Y explain the differences in observation in the both set experiment. I think this one is quite easy, but you have to use a table. It's easier for you to answer the question. Okay, so for experiment 1, right, where you can see the light bulb lights up. So first of all, let's suggest what X and Y is. So X is water. Y, you cannot put organic solvent. You must give an example of an organic solvent. You can use anything that you want. For example, the easiest one is methyl benzene. Okay, methyl benzene. Or benzene also can, up to you. Methyl benzene, ethyl acetate, hexane, propane, anything that is an organic solvent. So you should get 2 marks over here already. And now I have to explain the properties of each. So you say over here that for set number 1, okay, I'm going to explain here easier so that you all can understand better. Instead of writing at the bottom there because you cannot see it. Okay, so we know that, again, one more time, X is supposed to be water and Y is methyl benzene or any organic solvent. So here you can say that acid dissolves in water to produce what's it called? Hydrogen ions. Okay, and because of that, there's ions inside, electrical. They can be, it can conduct electricity. Then you can say that HCl at the bottom one remains as a molecule. So you put here acid ionizes in water to produce H plus ions. Presence of ions can conduct electricity. Okay, and then this one here, you say here acid remains, not acid, sorry, HCl. HCl, then this one change HCl also. HCl ionizes, HCl remains as molecules Okay, you can say no ions are present. To conduct electricity. Right, so very easy for you in this case. So that's enough explanation already lah. And this one over here, you can say same thing lor. You can say that HCl ionizes in water to produce H plus ions. So you see here H plus ions reacts with calcium carbonate. Okay, reacts with calcium carbonate to produce carbon dioxide gas. Okay, so lime water turns cloudy. And after that, the other one will be also very simple. This one also you say here, HCl remains as molecule and is unable to react with calcium carbonate to produce, I'm going to produce, like you say here, no gas bubbles are released, or no gas is released. No gas is released. Lime water remains clear. So I think this is enough explanation for you already lah. Okay, so again, just to explain to you guys one more time, the idea is very simple. It's just to understand how the properties of acid can be shown, right? In the first case here, can conduct electricity. Why? Because there are ions, right? HCl molecule can ionize or dissociate in water to produce hydrogen ions, and then can conduct electricity from there. And then for the second one, in the methyl benzene or any organic solvent, they can dissolve inside the solvent, but it remains as a molecule. So no ions are being produced. No ions means cannot carry electrical charges, so they cannot conduct electricity. So therefore, the light bulb will not be able to light up. Okay, for the next one, number 2 here, same thing, because HCl dissolves in HCl dissolves in water. It can produce hydrogen ions, which can then react with the calcium carbonate to release out carbon dioxide gas. So gas bubbles can be seen, and the lime water turns cloudy because there's a positive conformation of CO2. And then for the other one, right, notice that HCl remains as a molecule still because it doesn't dissociate. So then it will be unable to react with this calcium carbonate. No gas is released, lime water remains clear because there's no presence of carbon dioxide. So if you explain everything in detail, you should be able to get 8 marks in total lah. I mean, 6 marks for the explanation of each, plus the 2 examples that you give. Then therefore, you'll score maximum mark in this case. I hope that will help you a lot lah when it comes to knowing what to answer in this case. All right. So it's easier for me to explain to you here so that you all can use this for revision lah, in a way. Okay, now let's take a look at the section C. All right, number 11. So a group of students conducted an experiment to investigate the transfer of electrons at a distance in a redox reaction. What is meant by redox? So I think that's pretty simple. I would say that a redox reaction is a oxidation reduction that occurs simultaneously. So you say over here, a chemical reaction. Okay, a chemical reaction where oxidation and reduction occurs simultaneously. Okay, so you got 1 mark over there. And then for number 2, table 11 shows the list of apparatus and material needed by students. So you got a U-tube, you got connecting wire, galvanometer, carbon electrodes, bromine water, potassium iodide, and sulfuric acid. So I ask you to draw one label diagram to show the apparatus set up to conduct the experiment. The diagram must include the apparatus and materials given in table 11.1. In your diagram, draw the arrows to show the direction of electrons. Write the half equation for oxidation and half equation for reduction. Then you'll be able to score 5 marks in total. So in this case, let's try to do that together. So it's a YouTube experiment generally, so I don't think there's enough space over here. I'll draw a very simple one we'll do, okay? So a YouTube experiment is you draw a YouTube first, like this. Let me just redraw that again. Okay, I can also. No, that's right, okay. There you go, perfect U. Okay, something like that. And then you fill up this part here at the bottom here with one solution and then 2 separate solutions on top. And then supposedly there is a stopper and then there is an electrode dip inside. So this is a stopper. And then again, let's just draw another one over here. Let's say electrode. And then it's supposed to cover it up. Okay, and then it's supposed to connect itself through a galvanometer. And then after that, come back down. Okay, I don't have space, that's how this draw in this way. And then supposedly both are carbon electrodes. So you must label the carbon electrodes for both sides actually. Okay, and then point towards here. Okay, so you have bromine water on one side. Sulfuric acid over here. And then potassium iodide that side. Okay, so once you label everything correctly, everything should be done already. Then remember to also show the direction of electron flow. So electron basically flows from here to here. So just put that electron flow. Okay, so that should be correct already. This is how you draw it. I think very simple diagram will do. I'm not a Picasso, so I can't draw as nice as you guys. So this is roughly how it looks like. Okay. All right. So this is a YouTube experiment. If you do everything done correctly, it should be correct. Then the half equation here, you should be able to tell which is which. Bromine will act as a oxidizing agent. Okay. And the iodide ion will become the reducing agent. Okay, so what happens here is very simple. The iodide ion will release the electron to form iodine, and they release out 2 electrons. And then after that, you should have another one, which is the, what's it called? The bromine, sorry, the bromine. So bromine molecule will accept the 2 electrons to form bromides, 2 bromide ions. So this is the 2-half equation, okay, for oxidation and reduction. So just label this one as oxidation because it has increased in oxidation state. And this one should be reduction because it has decreased in oxidation state. So this is correct already. 5 marks in total. Right? There you go. So then after that, you're done already. The next question, B, table 11.2 shows the observation for the reaction between metal X with two different salt solution. So we have copper 2 sulfate, brown color deposit is formed, and zinc sulfate, which has no change. So you have metal X, which is unknown, but it can displace copper out from its own salt. It will not be able to displace zinc out from its own salt. So I would say that metal X here is more reactive or more electropositive than copper, but less electropositive compared to zinc. Okay, so based on the E naught value given, arrange the atom or ions in an ascending order of the strength of oxidizing agent and reducing agent. The more negative the value, the higher tendency of it to become a reducing agent. And the more positive the value, the higher the chance of becoming a oxidizing agent instead. Okay, so how do we arrange this? Very simple. I would say that you can arrange them in a sense like in ascending order. So you can put like Cu, X, and zinc in terms of increasing strength of reducing agent. So this is the strongest reducing agent. This is the weakest. You can also put the ions if you want to, but I'm going to put the metals. That's easier for you to understand. Okay, so if you want to put the ions, it'll be like Cu2 plus, X2 plus. Technically, I think X is 2 plus. And then over here will be Zn2 plus also. So either one of it, I will say or. All right. Okay, then how are you going to explain? The next one will be, next, explain why there are differences in observation obtained in table 11.2. Okay, so what you can say here is that, you see, right, in terms of negative value, X is still more negative than copper, so you can displace copper from its own salt. But, 0.13 is not higher than 0.76. So therefore, it cannot actually displace zinc. So you must explain in terms of the, what's that called? The values, the values of the E naught values, the standard electropotential values. So in this case, it's very easy. For set 1, so for set 1, you can say that the E naught value of X is more negative than copper, but less negative compared to zinc. Okay, then you say here X can displace copper from its salt, but not zinc from its salt. Okay, very simple. Then you say here, zinc is a stronger reducing agent compared to X and copper. All right, so it's actually easier to explain in terms of that. So in this case, you can also explain what is the reaction that's going on. So from the extension from this part, you can explain how it works. You can say that for the half equation, you can say that X being the more electropositive compared to copper will be able to release the electrons, while copper ions is the one that can accept the electrons. Why? Because they actually show you that there is a brown color deposit formed, so you must explain in terms of that as well. So in this case here, you say that X is more electropositive. It releases electron to form X2 plus. So then you can write a half equation also, like X becoming X2 plus, and it releases the electron. And then after you can also say that, technically speaking, for example, you can say that copper is less electropositive compared, it's less electropositive. Therefore, it accepts the electrons. Then you put here Cu2 plus 2 electrons, you'll be able to get copper. Okay, so that's how it works. So this is the new form, the new set of requirements that you don't put the negative value for the electrons anymore. So we're going to leave it as a 2e with that. Okay, so this is how you describe the whole experiment and the observations that you see. Once you explain everything in detail, you should be able to get 7 marks in total. Okay, so in this case, do explain which one is more. You can also explain in terms of zinc being more electropositive compared to X, so it cannot displace it in terms of that. So that will give you 7 marks in total. Okay, so another plus point over here, you can put there, zinc is more electropositive than than X. So that will be an extra point as well. So all this, you can get 7 marks in total. Okay. So that's pretty much about the question for B.
So for question C, a student carried out an experiment to study one of the factors affecting electrolysis. Table 11.3 shows the observation for 2 sets of experiment. Both experiments use carbon electrodes. So they give you the observation for the 2 different set of experiments. So for set 1, you can see the cathode releases a colorless gas bubbles, while at the anode, the gas is produced is greenish yellow in color. And then for set 2, you will see that colorless gas bubbles are released. And for the anode, also colorless gas bubbles are released. So supposedly, the colorless gas bubbles that's released in the cathode is actually hydrogen gas. And for this one, it's actually chlorine gas. All right, this chlorine gas is actually greenish yellow. And then for the bottom one, set number 2, this one also supposed to be hydrogen gas. And this one over here will be oxygen gas instead. Right, so what is being discharged here will be for both set 1 and set 2, it is hydrogen ions. And then for the anode, the ions that's being discharged will be chloride. And for the other one will be hydroxide. Just put OH, okay? So that's the outcome of the experiment. Now, number 1 here says, by using a suitable electrolyte, describe an experiment that can be carried out to obtain the observation as in the table 11.3. And secondly, you have to explain why there are differences in the observation at the anode. So the only thing that changes is the anode, because like I said just now, hydrogen gas is actually released on the cathode itself, right? So there's nothing that's changed. The only thing that's different is that one is chlorine gas for the set number 1, and the second one is O2. So what's happening here is very simple. There must be 2 different solutions. 2 of the same solutions, but different concentration. So for set 1, what I can do is you can actually use a concentrated salt solution that contains chloride ion. And for the second one, you can also use the same solution, but in a diluted form. So concentrated for set 1 and diluted for set 2. So the suggested answer that I'm going to give you will be here. For the procedure, because it's around 5 marks, you have to explain at least 5 points, but I have 6 points over here. Okay. So number 1 is measure 50 cm cube of 2.0 mole per dm cube of zinc chloride solution and pour the solution into a beaker, right? And then connect 2 graphite electrodes, or you can change the word graphite to carbon as well, to batteries or power supply through the wires. Then you're supposed to immerse both electrodes into the solution and then turn on the switch. So once the electricity goes through the solution, then electrolysis will begin. And then you're supposed to record the observations after around 10 minutes. And then after that, you're supposed to repeat the whole experiment again for set 2 using a more diluted solution. Now, the reason why I choose zinc chloride is because zinc chloride can enable us to get hydrogen ion being discharged at the cathode and chloride being discharged at the anode for a concentrated solution, and oxygen gas being discharged at the using the more diluted version. So if you were to accidentally pick, for example, copper 2 chloride solution, then you'll be wrong already, right? Because copper 2 chloride means the cathode side, the copper will be discharged instead of hydrogen. Because why? If you take a look at the electrochemical series, you will notice that the copper is lower than hydrogen in the ECS. So if in the electrochemical series, the lower the position of the ion, the easier it is to be discharged. So since copper is actually lower than hydrogen, copper will be chosen for discharge instead. So we don't want to use copper because of that. So instead of using copper, perhaps you can choose another salt solution. And my suggestion is zinc chloride, because zinc will not be discharged at the cathode. Instead, hydrogen ions will be discharged for the cathode.